video we saw with the powder metallurgy technique, PVD CVD process, mechanical methods, different type of grinding, powder metallurgy. By using powder metallurgy, what are the different type of applications? Powder metallurgy process or getting different finish mark, different parts. Further, we'll see with the chemical method of going with the powder metallurgy technique. So chemical reduction method is one of the chemical method. So here from the solid involves reduction of oxide by substance, iron oxide by carbon, tungsten oxide by hydrogen. So this is a batch process in which the ore can be reduced and is in static condition. So here in the chemical reduction you are going to add your two different materials and reduce it to the simple form at the required temperature and required time. If the reaction is happened, chemical reduction happens. So how sponge iron powder production from iron ore happens? So that way you are going to use coke, limestone or ore. In the clean you are going to do reduction, chemical reduction happens. Sponge iron, coke crushing happens. Magnetic separation happens to remove the waste. Annealing happens in the furnace. So further rotary screening is done, oversize is written, further packing is done. So like this the powder production from iron ore it is done. So overall temperature is 800 to 850 degrees centigrade. It is going to happen. So what are the limitations of doing the above processes? Cement copper produces byproduct is rather impure unless specific precautions are taken. Powder is quite fluffy, means it has low apparent density, which is not satisfactory for many copper powder application. Nickel powder produced by Sherritt-Gordon process is a typical hydrometallurgical method for production, in which the reduction of an ammonia aluminum solution of ammonical solution of nickel sulfate with hydrogen under a pressure of 1.38 or 200 psi at a temperature of 190 to 200 degrees centigrade in an autoclave carried out. Chemical decomposition means chemical reactions happens and it gets decomposed for the requirement like titan, zirconium, hafnium, thorium, uranium by heating the metal in the form of sponge, chip or turning or even compact metals in hydrogen. Decomposition of metal carboyls also it is possible. So by doing the certain process, chemical decomposition is possible. How the powders are characterized? Powders are characterized by the particle and shape, particle size and size distribution, particle shape. It may be internal or external. If you take particle size analysis is done, permeability of the material is checked. Microscopy, the particle size is seen. Still, if you want more clarity of the particle shape, you have to use SEM. So that is scanning electron microscope. If you want internal external, then stereology it is followed. Mercury porosimeter, like this it is done. The particle shape of the powder is characterized by the dimensionality of the particle and its contour surface. Here different types, one-dimensional, two-dimensional, three-dimensional particles. Outer surface shapes are shown. If it is angular, it has got one shape. If it is irregular, circular, spherical, flake size, porous material, irregular rod-like structures. Like this, different particle shapes characterization is obtained. Particle sizes mattered when bonding happens with the powder. So you see the grain size are very similar, means the bonding becomes easier in the presence of binder or in absence of binder also. So particle sizes of diameter irregular, we are going to get this shape. If it is polymodal, you are going to have this shape. If it is broad bounded, this shape you are going to have. This is some of the realistic particle size by the weight percentage size, means diameter it is considered and it is checked out. This is the output.